Hey, good evening. I figured I'd just record this video instead of trying to type it out because that just is easier. Okay, so for number 13, we've got two fractions. We're trying to add them together. So even if we were doing, something like this, 5/7 over 3/4, if we were adding these fractions, the first step would be getting a common denominator, right? We would multiply this by 4/4. We'd multiply this by 7/7. The bottoms would both be 28. We'd get some stuff on top, and then we'd add the tops. We'd add the numerators while keeping the denominator the same. Cool. We're going to do much of the same with this polynomial version, with this stuff with all the variables. Keep it purple. If we want a common denominator here, we've got c squared on one, we've got c on the other. We're actually just going to change this back one. We're going to multiply it by c over c so that both of the denominators are c squared. All right, we didn't change that first one, so we're just not going to change it. We did change the second one, so c times c becomes c squared in the bottom. Nice. 2 times c is 2c in the top. And now, just like we did with our number example, we're going to add the tops, add the numerators, and c plus 2c is 3c, minus 2 just hangs out in the back, and we've got a finished answer. Lovely. So again, the process was common denominator, kind of by whatever means necessary. Add the that's not even close to how you spell numerator. Add the numerators, and then always simplify. Cool. Let's move on to 23. Pick green. Again, the first step is going to be common denominator, right? We're adding fractions. Seems good. We can actually do this two ways. I'm gonna do it two ways for you. You can see which way you like better. I'm gonna move my face over here. The first way we're going to talk about is if I want to eliminate fractions, because it's easier to solve for x when there's no fractions, I'm just going to multiply by the denominators, right? So if I multiply by 4 on both sides, do this, those would cancel these 4s, right? And if I multiply by x on both sides, that would cancel this x. So this is looking like a good start. 4x times 5x over 4. The 4's cancel, we just get 5x squared. 4x times negative 3 over x, the negative stays. The x's cancel, and we just get 4 times 3 is 12. And then for 1/4 times 4x, the 4's cancel, and we just get x. This looks like a quadratic equation, or this looks like a quadratic, so we can move the x to the left-hand side. And now we can try to do the box and cross situation where we put -1 up here to factor this. The goal is to factor this. We put -1 on the top. We do a times c, so -60 on the bottom. And then we try really hard to find things that add to -1 but multiply to -60. And we say it's not just because it's late. We actually just can't do it, right? So it's not going to factor nicely. We're going to use the quadratic equation. Anytime a quadratic doesn't factor nicely, I guess, instantly bring out the big guns. So x is equal to -b plus or minus the square root of b squared minus 4 times a times c all over 2a. I'm not going to lie, that's a number. You can plug that into your calculator. Bingo bongo. The other way to do this question, 5x over, let me Scroll down. And honestly, this is kind of the best way. And by best, I mean most preferred by most people. Minus 3 over x equals 1/4. The other thing we could do is just combine the fractions on this side. Again, by multiplying by x over x and 4 over 4. So we get 5x squared minus 12 over 4x equals 1/4. And then we could cross multiply to get rid of the fractions. When we cross multiplied, this would be 20x squared minus 48 equals 4x. And then we can divide both sides by 4 because they're both divisible by 4. Looking good. We get this. And now we're back to our other problem, and we finish it out the same way by using the quadratic equation. All right, cheers. Hope that helped.